So if you missed yesterday, the assigned homework is on the board, and today we're going to take it further, and we're going to go 8 through 19. Again, answers are on homeroom, just the answers, and then the answers for tonight's homework I will be posting later today when I get a chance to upload it. So, you need to stop and ask questions as we're going. I will be, you're going to have 2 problems that you're working on, and I'm going to give the answers up there, and you can check your answers. If you're not getting my answer, then you need to raise your hand and say, hey, what did I do wrong? And you can't just sit there and say, oh, this is how I put it in the calculator. I need to see how your handwriting of what you did, because I can't tell in the calculator what you're doing. So anybody have an answer for me here? Huh?
No, I'm just kidding.
What do I want? Tells you what, 30? Huh? The equation, you have to know the equation to be able to solve the problem. You have to have the mole ratio. 1 point what? 78, yes.
Oh, that's what I said.
Oh, I thought you said 3.4. Oh, no. Sorry. 1.78. So let's work this out. The first thing I can say is go in there and highlight the information that you're given. What do you want to know? 38.5 grams. What do you know? So we want to get to moles of O2. And we know that we have 38.5 grams of H2O. So I am going from grams to moles. Can I do that in one step? No. So that means I know I'm going to start with what I know. So 38.5 grams H2O. And I know I need more than one step. So how many steps do we need? 2. So I need one more here. So I can already get my setup. And I know that that is what I'm going to need when I'm solving this. Now, if you're in Avid or you're talking to your friends that's in Miss Shelburn's class or in On Level, they set it up using something like train tracks rather than the way I do it. Either way you want to set it up, that's fine. The only thing is when you get to here, you're going to go what goes there, and it's always a naked one. Okay, so if you rather have that there and that keeps your structure, that's fine. All right, so we are in grams of water. So what's my first step? My conversion. Do I need grams, molar mass, or mole ratio? Molar mass. So the molar mass. So remember, grams of H2O needs to go on bottom. So what is the molar mass of water? 18.01?
I put 1.5.
Okay. Grams of H2O. And how many moles is that in? 1 mole of H2O. When you do grams, it's always over 1 mole. Now, my grams of H2O have crossed each other out. Now I take my moles of H2O, and I need to get rid of it, so I'm bringing it down to the bottom. So moles of H2O So I need 6, the number 6, which I find up here in the equation, and I care about oxygen. So 5 moles of oxygen. And that leaves me in moles of oxygen. So now when we put it in the calculator, it's, oh, keep doing that, 38.5 times 1 times 5 divided by 18.01 times 6.
No, substitute, I don't remember for the, five moles of oxygen.
No, I just want the coefficients. The coefficients is all I care about for mole ratio. Okay, now if you put this in the calculator and you got something wrong, so the calculator is a machine and it is programmed to do what it's supposed to do. So if you put it into the calculator as 38.5 times 1 times 5, and then your next step is divided by 18.01 times 6, the calculator is going by its program of order of operations. It's going to multiply everything, then divide it by 18.01, and then multiply that answer by 6. So the calculator doesn't know what you exactly want. We want 18.01 times 6 to be multiplied prior to my division. So you've got to put that in parentheses because the calculator is going to do just what you asked it to do, and that's going to be wrong. So the answer is
1.78.
1.78
Every time we do it on this,
moles
it's 64.
of O2.
But I'm putting everything in parentheses. And like I did it like 3 times.
That's okay. Nothing, I don't think anything can prevent me from failing this quiz tomorrow.
It's not tomorrow.
It is tomorrow.
Okay, so this is your problem. You put it in parentheses, but the bottom part, you put it into 2 parentheses. Let's just put one set of parentheses around the whole thing.
So we have these calculators.
You're fine. So this, the bottom has to be in one set of parentheses. So the calculator knows to do that math first before moving on. Okay, so now let's step to the next thing. We're going one step further. We are going to do mass to mass conversions, which means that we are going to go from the mass of our given. So we have the mass of our given, and we need to take that to the mass of our unknown. So the conversion factors we're going to need, we need the molar mass of our given, and we're going to need the molar mass of our unknown. This is the furthest one we'll go. Okay, so now we've been working just 2 steps. Now we're going 3 steps. So if you like it to put it where you have the whole lines, you've got one big long train track, and then you've got 1, 2, 3. So you should have 4 sections. So my very first thing is we have our balanced equation, and we want to know how many grams of SNF2 are produced if we have 30 grams of hydrofluoric acid. So I go to my setup. I'm going to write my given 30 grams of hydrofluoric acid. Huh? So, what was I going to say? What does that go over? a naked 1. So we have just a 1 there. Our answer needs to have how many sig figs? 4.
Okay, I was right.
4 sig figs. So now we have 30 grams of hydrofluoric acid, and we need to convert that to moles of hydrofluoric acid. So what do we need to use? Molar mass or mole ratio? Molar mass. So hydrogen is 1.01. Fluorine is 19.00. So we have 20.01 grams of hydrofluoric acid. And on top, we have 1 mole. Keep up with your units. Big thing, I come over there and I'm trying to help you. If I don't know what compound you're messing with, it's going to be hard. And it's hard for you because you're going to get confused because you have 4 different compounds and you're not going to remember which one you're dealing with. So I am in moles of hydrofluoric acid, and my next step here says step 4, says to write, using the balanced equation, coefficient of your unknown over your given. So our unknown coefficient is 1, and that is going to be over 2 moles of HF. Now I'm in moles of SNF2, and it says to change my moles of unknown to the measure required. Our measurement required is grams. So how am I going to go from moles to grams? Molar mass of SNF2. So F is 19, and there are 2 of them. SN is 118.71. And one of the big mistakes too is I see you guys multiplying these. 156.71 grams per 1 mole. So which one goes on top? Which one goes on bottom? Moles goes on bottom. So for every 1 mole of SNF2, it is 156.71 grams. So put that in the calculator, get me an answer. So give me 4 sig figs. 117.5. 5 grams of SNF2.
Do we round in chemistry? I said we don't, but.
On the periodic table you round, and then yeah. I mean, if you're going for, you would round, yes.
So,
To get to your sig figs. So if it was 117.45, I need to have 4 sig figs. So I'm going to round it up to 0.5.
That's what I did.
Yes.
Is there any way to check your answer or anything?
To
Like your final answer?
your final answer? Not really.
Oh yeah.
I mean, just go back and make sure you did your steps the correct way and you have your ratio. Go back and check your molar mass. If you come up with a molar mass of 2,000, then there's something wrong. Okay, that means you probably multiplied, then added. And then that's one of the reasons why I put the answers on homeroom, so you can go back and check your answer. But on the day of the test, the answer is not going to be there. But it's there to help you out. So let's do one more, and then you're going to work 2 on your own. So now I want to know how many grams of silver will be formed from 12 grams of copper. So I start out with what I know. I know I have 12 grams of copper, and I need to get to grams of silver. So the first thing we're going to have to do is write what we have. We have 12 grams of copper. So we need to change that to moles. So how am I going to change grams to moles? Molar mass. And the molar mass of copper is 63.55. 5 grams of copper, and that's over 1 mole of copper. So then you have to decide which way are you going to set the ratio up. Who goes on top, who goes on bottom? Grams goes on bottom, and the number always carries with grams. And that is in 1 mole of copper. So now we're in moles of copper, and we've got to get to moles of silver. So our next thing says use the coefficient of your unknown over your given. So our unknown is 2 moles of silver, and that is over 1 mole of copper. So now we're in moles of copper or moles of silver, and we need to get to grams of silver. So how am I going to go from moles to grams? Molar mass, and so I need the mass of silver. So 107.87 grams of silver, and that's over 1 mole of silver. So then you have to figure out which way am I going to put that in. Which goes on top, which goes on bottom? 107.87 grams of silver over 1 mole of silver. And what do we get? I need 3 sig figs. 40.7?
Yeah.
40.7 grams of silver. Yes, what's your question? No, because we have moles of silver, and so that needs to go on bottom here. Okay? So make sure as you're doing this that what goes on top was carried down to the bottom in your next step. Breathe. Okay, so any questions? So now I'm going to put up 2 problems for you. You're going to get about 10 minutes to work it. If you need a setup sheet, then there's some setup sheets over there at the corner table. But your answer to the following needs to be in 3 sig figs. So this is the answer you should get. For the bottom one, it has 100 grams. How many sig figs is in 100 grams in that 100? How many sig figs is there? There is just 1, because those 2 are trailing. So I want this to be a 3 sig fig answer. So what I'm going to do is we are going to add a decimal right there after the 100 to trap those zeros, so that your answer will be into 3 sig figs. And you should get 191 grams of carbon dioxide. So start working those. I'll come around and I will help you if you have any problems. So my very first thing says what mass of barium chloride is required. So that's my question mark. I go and I have sodium phosphate, so I have 48.6 grams of sodium phosphate. So all my numbers that I need to deal with are in the word equation. Everything else doesn't matter. So I know I am dealing with mass and another mass. So that means I need to deal with the molar masses of these guys. So if we go and we find the molar mass of barium chloride, it is 208. Somebody tell me what the decimal is. $208? Okay. And if we get the mass of sodium phosphate for simplicity, it is a mass of 164 grams per mole. So I'm going to write down what we are starting with. We're starting out with 48 grams of sodium phosphate. If it makes you more comfortable, put that over a naked 1. Grams of sodium phosphate is on top, and we need to get rid of it. So that means that in my next step, grams of sodium phosphate goes on bottom. When we're talking about molar mass, the number, the 208, always goes with grams. And you always have, not 208, sorry, 164. And that is always in 1 mole of whatever compound we are dealing with. You cannot have grams of one compound over moles of a different compound. It's not the conversion factor. Now we need to get rid of our moles of sodium phosphate. So we go to our unknown over our known. So, and we get these numbers from the coefficients. So we have 3 moles of barium chloride over 2 moles of, no, remember you switched them. 2 moles of sodium phosphate. Now we need to get rid of our moles of barium chloride, and to do that we need to convert to grams. So for every 208 grams of barium chloride, there is 1 mole of barium chloride. Do the math, punch it in the calculator, and you should get 92.6 grams. 92.8 is fine. All right? If it's close, it's fine, yes. If you're doing a multiple choice test or quiz, then you find the one that's closest to your answer. Okay? So the next thing is, let's do the next one. So we have 100 grams of ethanol. And I want to know how much carbon dioxide is going to be made. So we start with 100 grams. What is the molar mass of ethanol? Carbon is 12, there's 2 of them. 46? 46 grams of ethanol. So what goes on top? 1 mole of ETOH, of ethanol. So what's our next step? What's the ratio? 2 mole of CO2 on top, and 1 mole of ethanol on bottom. So we need the molar mass of carbon dioxide. So what goes on top, what goes on bottom? 44 grams of carbon dioxide goes on top, while 1 mole of CO2 goes on bottom. Plug it in, and you should get that as your answer. One of my checks would be go back and make sure everything crosses out. Looks good. We're left in the unit that we need, and we are to the correct sig figs.
You should do this on the test. Like, give us the answer, and then we can work towards it.
Well, if she took the work, we could count.
That's like so much more grading for her. She's great.
Oh yeah, that's true.
So the next thing is your homework. So if you take a look at your homework, question number 11. So on your homework, question number 11 says, aluminum oxide breaks down into its component parts. So aluminum oxide decomposes into what? Al and O2. And then you come back and balance it. 2, 4, 3. And now you're ready to solve. Okay.
We don't have to do that. Or we do.
No, those are what you're doing tonight. The ones that aren't circled from last night.
So we're doing 8, 11, 12, 13, 15, 16.
And on the back page is 19.
Oh, wait.
So I'm going to go take a picture of the answers right now and upload those to homeroom.